Hey everybody, MS Farzan here, and welcome back to this video series on learning C# and Unity for digital tabletop game development. In the previous video, we looked at how to create our own functions, and you have reusable functions that we can apply anywhere in our code. And we're just about ready to actually start work on our game development, but there's one more concept that we need to cover before we're comfortable entering the wide world of game development in Unity. And the way we're going to handle this is by looking at conditional logic and also loops, which are not necessarily interrelated, but we'll be using them in tandem here so that we are primed and ready to begin our game development journey. Let's get started. In the previous episode, we looked at creating a new function that takes an integer I and a newer function that takes an integer j and a string new string as parameters, and then we called those functions, passing them different arguments. So we're going to delete newer function for now, just to clean things up a little bit, and just work with new function so that we just have a little bit more of a clean slate here. Now, what if I want to do things that are dependent on other things? So like maybe I want my function to do a certain thing based on the number that's being passed to it, or I want to display on my screen a red card instead of a blue card. I'm going to need to do what's called conditional logic. And conditional logic, that just means if something, do something. If something else, do something else. So right now I have my new function and I'm passing it one argument, which is 1. So I'm going to create some conditional logic within my new function, which is going to determine what's going to happen when I call that new function. And I'm going to say if, remember I'm calling an integer, I'm looking for a parameter, which is an integer called I. I'm going to say if, and then in parentheses, if I is greater than 5, and then I put curly braces, and I'll say do logic. Else, if I is less than 5, do this other thing. Else, do a third thing. So I have 3 conditions here. I say if I is greater than 5, do something. Else, if I is less than 5, do some other thing. Else, which the only other case here is that I is equal to 5, I'm going to do this third thing. That's called creating conditional logic, which we might have to do in our game. Like if my health is over, my hit points are over 20, do something. If my hit points are less than 20, do something. Or if my hit points are equal to 20, I don't know why you would do this, but you might, then do this third thing. Going to delete this line down here. And actually I'm going to delete the string number string and just say debug log I. Okay, we haven't actually added any logic here. We're just saying that if I is greater than 5, do a thing, and other conditional logic. In fact, let's move our debug log and actually create conditional logic here. And we'll say if I is greater than 5, debug log greater than 5. Semicolon to let the computer know that we're done with that line of code. Else, if I is less than 5, debug log less than 5. Else, if, I'm sorry, otherwise we will say debug log 5. So when we call this function, let's call it a few different times. Let's call 6 and 5. So we're saying that with this new function, when we call it, it's gonna expect a parameter that's an integer, and when we call this function with these different arguments, 1, 6, and 5, if I is greater than 5, log to the console that it's greater than 5. If I is less than 5, log to the console that it's less than 5. Otherwise, it must be 5, so log it to the console that it's 5. And now we're calling it with 3 numbers in our start method. Let's hit play. And we see less than 5, greater than 5, and 5. So we're using conditional logic to determine how we're going to log to the console, or what we're going to log to the console, I should say. We're also learning about 3 different operators here. We're saying that 3 different ways of evaluating things within C#. We're saying is if I is greater than, less than, we could say else if I is equal to 5. But we'll run into an issue here where we'll say cannot implicitly convert type integer to Boolean. We haven't dealt with that yet, but what I want you to see is that we're trying to compare a value with another value. We're saying that if this value, whatever I is, if it's greater than another integer, 5, that is we should do something. If it's less than 5, then we should do something. But when we start saying, when we want to say equals, we can't just say equals, because equals is something that C# uses when we're declaring a variable, and we're trying to say that we're basically not using the right syntax here. We're not using the right way of comparing these two values here. We're trying to say here what the computer thinks we're trying to do is say that I should be equal to 5. What we're trying to ask is if I is equal to 5. So we have to put 2 equals here, and that's the way that we compare these two numbers. And we're saying else if I is equal to 5 is different from saying I should be equal to 5. So if I were to say I equals 5, that's me telling the computer I should be equal to 5, versus else if I equals 5, that means is I equal to 5. So that's how we would do that. Or if we wanted to know if I is greater than or equal to 5 or less than equal to 5, we could do that as well. That's just like the way that you do things in C# and Unity. But in this case, we're just creating 3 types of conditional logic. We're saying if I is greater than 5, do something else. If I is less than 5, do something else. Do this third thing. Cool. That's the basics of conditional logic. Now, let's say if we want to do certain things within this code, we could actually, let's just create a new function. What the heck? We'll say bring back our void newer function, and we'll also take an int I, or you could call it int j if you wanted to separate your conceptually separate concepts. In fact, let's just do that. Let's just make it neat that way. So it'll take an integer j, and let's say that we want to apply. We want to do things a bunch of times. So we want to print to the console a bunch of different things, or we want to run a function a number of times. And rather than just writing that over and over again in our code and just copying and pasting, we want to do what's called a loop. We want to do something a number of times in a loop with certain conditions. The easiest loop, or the most common loop that you're going to use, is called a for loop. We're going to say for int I equals 0. In fact, let's call this, I've backed myself into a corner here, because we'll use I, usually when you're writing a for loop, you'll use the integer I. It's just like the convention of doing that, but and I want you to be familiar with that. But we've also used I here, and I don't want you to get confused. So let's just separate these into different concepts. That we are calling an integer I here, but we're also going to be using it in our for loop here, which has nothing to do with anything. It's just the convention that you do. You could call this anything here. This one here, we could call it int L or int Z or int integer, anything. It could be called anything here. It's just a variable. For int I equals 0, semicolon, I is less than 5, I plus plus, and then curly braces. Let's unpack this. This is called a for loop, which means that we're going to loop over certain conditions and do a thing based on those conditions. The syntax of this says that integer I is equal to 0. That's a different integer than this I that we have up here. Semicolon. We're going to run this loop while I is less than 5. So I only want you to do whatever is between these curly braces while I is less than 5. And every time I run this loop, I want, every time I run whatever's between these curly braces, I want to increment I by saying I plus plus. That just prevents us from having an infinite loop. You can imagine that if I didn't have this I plus plus line, I would always be less than would always be equal to 0, and it would be less than 5. So we would just be doing this to infinity and beyond because we never increment I. So this is the way we prevent that from happening, by saying each time you run whatever's between these curly braces, increment I, so that I will be, after we do it once, I will equal 1, and then 2, and then 3, 4, and we'll just stop when I is equal to 5, because I will no longer be less than 5. And then we'll say for int j, debug log your number is plus j. So in our start method, instead of calling new function 3 times, let's call newer function and pass it a parameter or an argument of 5. So we should see for newer this for loop will take our integer j, which is right now we're saying that it's 5. 5 times I want it to loop over, I want it to run this loop, and I want it to log to the console your number is plus whatever number I have given it. So it should do it 5 times. That's how you run a for loop. Hit play. And I see, if I uncollapse this, I see that it's done that. It's done, your number is 5. Cool. Well, that's interesting, but how can we add to that functionality? Well, let's say that for this for loop, rather than just doing nothing, we can say j++, and then so we're actually doing something to the integer that's being passed to it, and then logging it to the console. So now when I hit play, I see 6, 7, 8, 9, and 10. That just means that we've fed it this number, which is 5, and then it has it has logged to the console that it has added 1 to j every time that it has run that loop. What would be cool is if instead of calling new function here, this original function, we actually call it here. And we say new function j. So we have this function, which is called new function, and it does some conditional logic for us. It takes an integer, which we're going to look at in just a second, and it just compares it, and it says if it's greater than 5 or less than 5 or equal to 5, do things. And we're using it elsewhere. We don't have to declare, we don't have to log to the console anymore within this newer function. We just say that when we give newer function a number, loop over that number and do something to it. In this case, we're adding 1 to it, and then run this other function, which is new function, and compare it to 5. We'll save it and hit play. And then we see 5 times it's actually greater than 5. Let's add it. Let's use a different number here. Let's just say new function, and we'll say 1, and see what happens. So this 1 gets what we call newer function, and that 1 goes into this as an argument, and then we start with 1 being j being equal to 1. We loop over it and we add 1 to it every time, so it should be 2, 3, 4, and 5, so on and so forth, as much as we want. And we're calling within this newer function, we're calling new function, and we're using conditional logic to say that, well, if it's if this integer is greater than 5, do something, and so on and so forth. So we're abstracting quite a bit to use both conditional logic as well as a for loop to handle some work for us. And let's see what happens there. We hit play, and we see that when the game starts, well, we know that j is equal to 1 and it's less than 5. And then we add to it several times until it equals 5. And then eventually at the end of that for loop, when we've run it 5 times, it's greater than 5, which is super cool. That just means that we've created, not only created a function that does some conditional logic and logs to the console based on that logic, but we've also used a for loop to increment a number that we fed to it and seen some change based on that logic. And that's the basis of using both for loops and also conditional logic to make things happen in your game. So like I said, you could determine, you could say that if you're doing damage, you could run a for loop to determine that you do a certain number of a certain type of damage or a certain number value to your damage based on how many numbers are fed into it. Or you could use conditional logic to say that, if my health is 0, then I should display something to the screen versus if it's greater than 0 or less than 0. So those are going to be handy things that we'll be using throughout our code. And I'm happy to say that now that we've got all of these basic concepts under our belt, we can actually start building our game functionality for our different types of games, which is what we'll start looking at in our next videos. So I think your homework for this section should just be to Google or Wikipedia conditional logic for C# and also for loops and different types of loops, just so you're familiar with the concepts that we can use in our next videos. And try some things out here. Try making I greater than 10, or see if I is less than or equal to 5, or maybe start using strings and use equals to determine if things are equal to one another versus when you're just declaring that they should be equal to something. And we'll take a look at more complex logic and actually applying that game logic to our Unity editor and start getting comfortable using the Unity editor for card games and board games and different types of tabletop games in our future videos. I hope this video has been helpful for you. If it has been, please like it and subscribe to my channel. I'd also love it if you check out my games at entromancy.com or nightpathpub.com/entromancy. And better yet, share them with someone and get the word out about entromancy. I'd love for people to know more about my games and books, and we'll see you next time.